Hi, I hope you're having a wonderful day so far. Today we are looking at section 6.7, which is going to be looking at negative integer exponents. And at the very end, we're also going to do a little bit of scientific notation. So negative integer exponents are just negative exponents. And what you do is if you have a negative on the top, you just send it below on the fraction. Or if it's on the bottom, you bring it up top. So for example, if we had x cubed over x to the fifth, we know from section 6.6 that we could subtract those exponents and we would get x to the negative 2. Okay. Another thing that we know is if we have x cubed over x to the fifth, we could rewrite that as x times x times x over x times x times x times x times x. And that we could cancel those out. So we got 1, 2, 3 of them we could cancel out. A lot of people want to say I have nothing left on the top and they want to just leave it as x squared. But we don't do that, okay? There is still something on the top. There's a little hidden 1. Leaving our answer with 1 over, I have x times x, so x squared. So this here is showing you that if you have a negative exponent, it's the same thing as putting it down below on the fraction. Those are the same thing. And all of your homework and quiz and exams, everything, it's going to say make sure that everything is a positive exponent. So we're just going to grab it and send it to the other side of the fraction bar. Okay, so let's let you try a few of these. How about just those first 3 to start? Okay, so hit pause, give those 3 a try, and we'll see how it goes. Okay, so if I have m to the negative 3, I'm just going to send that down below on my fraction, right? So m to the negative 3 is 1 over m cubed. Negative 3 is all to the negative 2, so I'm going to send that all below. So it's going to be 1 over, it's that full negative 3 to the 2. A lot of people try to change that negative with the 3, but remember, we're only talking about negative exponents. It's going to keep this base the same. So that stays negative 3, even though we sent it below, but what we changed by sending it below was that the exponent is no longer negative. That's the part that we changed. We can reduce this because negative 3 squared is negative 3 times negative 3, which ends up being a positive 9. Now on this last one that I showed you so far, we have this negative exponent. So to make him positive, we send him up top, leaving us with x to the 7th. Okay, it would look kind of silly to put 1 times x to the 7th, but if it helps you out, go ahead and do it and rewrite it as x to the 7th. Let's show you the next group of 3. I think I can squeeze them all on there. There we go. Go ahead and try these. Hit pause. Press play when you're ready. Okay, so now I'm going to circle everybody that has a negative exponent. So that's just this top one. And we're going to send him below. But when we do that, what do I still have up top? I still have a 1, right? It doesn't change the whole problem. It's just leaving that 1 up top. So on the bottom now, I moved that x to the negative 4th down. So now it becomes x to the positive 4th. And that y squared, he didn't move. He just stayed there. In this next one, grab everybody with a negative, send them to the other side. We already had that x cubed up top, and we just joined y to the 7th with it. It would look kind of weird to put over 1, but if it helps you out, mathematically, it's still the same thing. It just looks kind of silly. And finally, this last one, we have a few things going on here. I'm going to start by just writing the 4 and the 7, because nothing changes with those guys. 4 and the 7. Is there anything else that we aren't going to touch? How about that b to the 4th? So I'm going to write that b to the 4th. That's going to stay right there where it's at. That a squared, though, is negative. So to make it positive, we send it to the opposite side of the fraction. So we'll put him on the bottom. The c to the negative 5th, we want that positive. So we're going to send that up. So it's c to the 5th. Okay. This next one is going to get kind of crazy here, because there's so many different ways that you can do it. Go ahead and just give it a try, and we'll see how you did. Okay, so go ahead and take your time, try this one. So if you look in your book, there's a whole nother rule with this one, but I feel like if I tell you too many rules, they're going to kind of get lost. So if you look in the book and you see that other rule and you like it, go ahead and use it. It is a teensy bit shorter, but instead of making you learn a new rule, I'm just going to go ahead and solve this by using the rules that you already know. So the first thing that I'm going to do is I'm just going to apply this negative 3 to every single piece. Okay, meaning that now my problem looks like this. It's now 2 to the negative 3, a squared to the negative 3, over 3 to the negative 3, and b to the 4th to the negative 3. Okay, now there's so many different ways we could go with this. Let's do this. Let's go 2 to the negative 3. You know here with this a to the 2 and then negative 3, we can multiply, right? So let's do that. Let's do a to the negative 6th over 3 to the negative 3, and again multiply b to the negative 12th. Now, I hope I'm going to run out of room here. Let's grab everybody that's negative and send them to the opposite side, which if you look, is every single piece, right? So everything on top is going to go to the bottom. So now we're going to have 2 cubed, a to the 6th on the bottom. And we're going to grab everybody that's on the bottom, because they're all negative, and move them up top. So now it's 3 cubed, b to the 12th. And one final step is just to simplify that 3 cubed is really 27. B to the 12th over 2 cubed is 8. A to the 6th. All right, that one is done. And now for I have one more that I want us to try. Again, there's lots of different ways to do this one. So I'll show you the way that I did it. But let's do one more before we move on to scientific notation. Okay, so try this guy. Okay, so I have a to the negative 5th, b to the 7th, c to the negative 2, all times a to the negative 3, b to the negative 2, c to the 6th. A lot going on, right? So many different ways to do it. The way that I started this one is I saw this a to the negative 5th, a to the negative 3. And remember is that we can combine those exponents since we're multiplying. So really another way to look at this is a to the negative 5 minus 3. So it would be a to the negative 8. B, we have 7 and negative 2. If I combine those exponents, I get b to the 5th. And finally C, combining those, negative 2 and 6, I would get 4. So now let's circle everybody that's got a negative exponent. Looks like it's just that a to the negative 8. So we're going to write that down below to make it positive. So we get a to the 8th down here. And then b to the 5th, c to the 4th is still up top. So our final answer is b to the 5th, c to the 4th, all over a to the 8th. All right, to finish off this section, we have scientific notation. And what scientific notation says is that we have n times 10 to the nth, where n is at least 1 but less than 10, and is going to be in a decimal with m the little exponent being an integer. So the first one, and I find that most people are pretty good at these, convert to decimal notation. So I have two of them written here, 7.893 times 10 to the fifth, and then the second one being 4.7 times 10 to the negative 8. So a lot of people actually already know what to do. If you think that this looks familiar, remember you're going to grab that decimal and you're going to swing it that many times, one direction or the other. Okay, so that's your hint. So go ahead and hit pause, give it a try, come back when you're ready. Okay, so 7.893 times 10 to the fifth. 10 to the fifth, that's going to be a huge number, right? It's a 1 with 5 zeros. So what we're going to do is we're going to grab that decimal and we're going to swing it 5 places. I'm going to actually go ahead and rewrite it first. Let me go 7.893. So I'm going to go 1, 2, 3, 4, 5. And those last two that we don't have anything there, we're going to put in the zeros. So that final answer is 789,300. So it's kind of hard to see. I'll write it nicely off to the side. 789,300. So that is 7.893 times 10 to the fifth. So if 10 to the fifth got bigger, okay, we got this big number. What do you think is going to happen with 10 to the negative 8? It's going to get smaller, right? So which direction should we go now? Now we're going to go the opposite way. So it's going to make it be a very, very, very small number. So 4.7, grab your decimal. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. And put them right there. Fill in our spaces with zeros. And you don't have to do this, but it makes it look kind of nice if you put a big zero out front. It just kind of helps your eye catch that decimal right there. So our final answer looks like we've got 1, 2, 3, 4, 5, 6, 7 zeros and then 4 sevens. So 4.7 times 10 to the negative 8 is a super, super small number. Just 2 more examples here. To finish it off for the day, convert to scientific notation. So take a look at these two. Now we're going backwards. So you need to figure out what is going to be that big number out front that is 1 or more but less than 10. And then figure out what you're going to multiply that by 10 to the what. Okay, so go ahead and try both of those. So for the first one, I have 83000. For the next one, I have 0.0327. Give it a try. Okay, so in this first one, oops, getting away from me there. So in this first one, would this be correct if I put 83 times 10 cubed? A lot of people want to do that. That is not correct because remember this first one has to be between 1 and 10. So if you're putting the decimal here, even though you're swinging the decimal 1, 2, 3, this is not good. Okay, so don't do that. That first number has to be between 1 and 10. So where could I put the decimal to make it be between 1 and 10? I could put it here between the 8 and the 3 because I would have 8.3. That number is between 1 and 10. So times 10 to the how many spots did my decimal move over? Let's see. 1, 2, 3, 4. So 83,000 written in scientific notation is 8.3 times 10 to the 4th power. Now in this next one, where should I put the decimal to make sure it's between 1 and 10? Okay, I don't want to put it before the 3. That wouldn't be between 1 and 10. I don't want to put it, I'm just going to write it and I'll erase it. 32.7, that's not between 1 and 10. I want to put the decimal here. 3.27, that number is between 1 and 10. So I have 3.27 times 10 to the, what do you think? This one's going to be negative 2. And a lot of people ask me, like, how do I know when the exponent is going to be positive or negative? And I would say after more practice, you're going to get used to it. But you can always go back and double check because up in these first ones, those ones were probably a little bit easier to kind of see. So now you could just check your work. So you could go 3.27. Negative 2 means get smaller. So 1, 2. put my decimal, and then you would see that you got your original. Or like in this one, 8.3, a number getting bigger, 1, 2, 3, 4, fill it in. And then you could check to see, yeah, that was the original. Okay. All right, so that wraps up another day. You're doing awesome. Good job. I hope you have a fantastic rest of your day.